Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, esteemed guests, faculty members, and students, good morning and welcome to the International Guest Lecture on Agricultural Electricity and Energy. We are gathered here today for an insightful session as part of our 3-in-1 program hosted by the Agricultural and Biosystem Engineering Study Program. I am Fatinia Kamila and I have the privilege of being your Master of Ceremony for this occasion. Before we proceed, I would like to extend our heartfelt gratitude to everyone who has joined us today. Your presence is greatly appreciated. This lecture wouldn't be possible without your support and enthusiasm for knowledge sharing. Today, we are fortunate to have a distinguished speaker with us, Dr. Lee Wei-Woon, a renowned expert from the University of Malaya, is here to enlighten us with her insights and expertise. I am also graced with the presence of our respected invited guests, the head of the Department of Agricultural and Biosystem Engineering, Dr. Ahmad Adi Sulianto, the head of the Agricultural and Biosystem Engineering Study Program, Dr. Rini Yulianingsih, and our esteemed faculty members who have joined us today. This lecture is a part of the 3-in-1 program hosted by the Agricultural and Biosystem Study Program, aimed at enriching our understanding of crucial topics within the field of the agricultural and biosystems engineering. Alright, I would read out the rundown for International Guest Lecture, which is divided into 4 parts. The first, the welcoming speech from the head of the Department of the Agricultural and Biosystem Engineering. Second, keynote speech that will be led by the moderator. Third, Q&A coming from the audience. And fourth, photo session as the last program. Ladies and gentlemen, now we move to the next agenda. It is the welcoming speech from the head of the Department of Agricultural and Biosystems Engineering, Dr. Ahmad Adi Sulianto. Dr. Ahmad Adi Sulianto, please proceed to the stage.
Thank you very much, Master Ceremony. Not Master actually, yeah. Miss Ceremony, okay. Thank you very much. Good morning, everybody. The Honorable Professor, Associate Professor Dr. Lee Wei-Woon from University Malaya. The Honorable Head of Study Program, Dr. Rini Yulianingsih, and the Honorable all academic staff from Biosystem Engineering Department, and the last but not least, my student. Good morning, everyone. Okay, let's thanks to God, to Allah Subhanahu wa Taala. Today, this morning, we can meet in this room with a nice weather, I think. And today, we would like have a 3-in-1 program. I would like to explain to Professor Lee that we have a 3-in-1 program, not only sample, we have 3-in-1, but also in lecture. Because we have one professor from the abroad, from the university in abroad, one lecturer from our department, and one practitioner, or the we take from the industry. In this case, in the energy system, we collaborate with the state electricity company. We use PLN, Pembangkit Listrik Negara in Indonesia. So we have a 3-part, we call a 3-in-1 program. And every year we have some lectures that we invite professors from the abroad. Okay. For this morning, thank you very much for your coming, and please enjoy Malang. Actually, this is first time for you. Okay. I will have a short explain about biosystem engineering department. We have three undergraduate study program. Firstly, agricultural biosystem engineering study program. Secondly, environmental engineering, and the third, bioprocess engineering. All study program already accredited by the international. So in this study program, we already accredited by the ASEAN, the accreditation from the Germany, and also from European Engineering Accreditation Board. So in case of this study program, we already accredited and have the same position if we go to Europe. And others, the environmental engineering also we already accredited by the Indonesian Engineering Education Board, we call IAB, that formed by the Japan Accreditation Board of Engineering and also American Board of Engineering. So, and the last, bioprocess engineering, also same with the biosystem, agricultural and biosystem engineering, already accredited, full accreditation by European Accreditation Board and also from the Germany Accreditation Board. This is the our accreditation status for our study program in undergraduate. Actually, we talking about the energy, all of study program we related with the actually with the renewable energy because nowadays we have a limited resource of the coal energy. So next, I hope the next my student can pursue the master degree in your university, and also we have around 10 staff, academic staff that in next year should be pursue the doctoral degree. One of them is Agung. So please, if you have a chance to have a scholarship, just accept Agung as your doctoral student. It's a part of my duty because we have a planning to increase the competency of the academic staff to pursue doctoral degree in abroad, especially in university that have a good ranking, like University of Malaya. I think it's 100 in QS, I think. It's very good. Okay, so for my student, this is an opportunity for you to join this lecture because you know that Prof. Lee is from the University Malaya, one of the 100 ranking in the world, university in the world. So I hope you have a motivation to have a master degree like Pak Agung that maybe 3 years ago or 4 years ago he conducted master degree in University of Malaya and got a full scholarship, I think. Yeah. It's so you have a chance like us, Pak Agung. So please have good ability in English especially, and also in your field, in agricultural engineering, especially in energy. And nowadays we face with the renewable energy. Okay, I think it's enough for me. Thank you very much with Dr. Lee, and I'm sorry I cannot participate in the full of your lecture. And we will continue and discuss for the potential collaboration in this dinner with our dean. Actually, and please enjoy Honeskin, enjoy Malang. I think you have 3 days or 3 days, I think. Okay. Thank you very much for this ceremony. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Ahmad Adi Sulianto, for the very warm welcome. Now, the international guest lecture is officially open. Today's lecture will be a stimulating exchange of ideas and knowledge. To ensure the smooth flow of the session, we have a dedicated moderator who will oversee the presentation and the subsequent Q&A session. So, moderator, time is yours.
Okay, well. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. Thank you for Master of Ceremony. Today we are privileged to have a gather here in Magnificent Hall of the Faculty of Agricultural Technology to be embark of the journey of the knowledge and exploration. And before we proceed, I would like thanks to the distinguished speaker, Dr. Lee Wei-Fun from University of Malaya. And I would like to briefly explain about our audience today. Our audience today consists of the bright and inquisitive students of Agricultural and Biosystem Engineering study program who have enrolled the subject of agricultural electricity and energy, and they are very eager to delve deeper in the world of the agricultural renewable energy. And before we move forward, let me briefly explain about the introductory curriculum vitae, and you can see on the slide. Okay, next. Okay, this is the areas of her expertise. The first one is about the colloid and interface sciences, like a packaging emulsifier and so on, and then the nanomaterials. This nanomaterial is the specific field in her laboratory. It is about the bio-based nanostructure materials and nanocellulose derivative. And this is not the last one, but still several expertise that we cannot explain all. But one of them is a biomass conversion technology. This is about the catalytic conversion of solid and liquid-based biomass. And about her academic qualifications, her bachelor, master, and PhD is pursued in University Putra, Malaysia. Okay, next. Okay, this is the several memberships that Dr. Lee follows. The first one is the American Chemical Society, or ICS member, in 2019 to 2022. And then the Malaysian Institute of Chemistry, Institute Kimia Malaysia, and the last one is the Energy Institute for the other institution. And this is the award, several award of and the stewardship that Dr. Lee achieved. The gold medal of one of wonder facile production of the cellulose nanomaterials from lignocellulose biomass. This is an international research and innovation symposium, and the rest you can see on the slides, like the world top 2% scientists in 2022, and so on. Yeah. Okay. Next. This is about her publication, maybe. Yeah. You can see on her Scopus or Web of Science. There's a lot of publications. This is the H index. The H index of her, the Scopus H index is about 38, and WAS index is about 35. That is so excellent. Okay, next. This is the several research project. Mostly it's about the nanocatalytic or nanocellulose material. Okay, next. This is the last one. This is about the her patent that she got. The first one is about national patents in terms of cellulose nanomaterial and method for obtaining the something. And photoreactor design for the treatment of fluid, photocatalytic gas conversion reactor, and for the international patents, you got a method of in terms of the method of production biodiesel using heterogeneous catalytic system. Okay, maybe this is the briefly curriculum vitae of Dr. Lee. Before we move forward, let me explain about this session. We prepare the embark of intellectual journey. I would like to remind the audience, the participant, all of the students, to save any question you may have for the end of this lecture. We will have a dedicated Q&A session where you can engage with Dr. Lee and seek the clarity on this aspect of the topic. Without further ado, I invite all of sit back, relax, and open your mind. We are of knowledge that Dr. Lee Foon is about to share with us. Ladies and gentlemen, all of the students, the international lecture on agriculture, electricity, and energy commence. Dr. Lee, time is yours.
Okay, hello all. Good morning. Selamat pagi. Okay, so I am Lee. Okay, come from this University Malaya, which is in Kuala Lumpur. Okay, probably I can stand there, right? So is it more comfortable in this side? Okay, so yes, also I'm come from University Malaya, as I mentioned just now, and basically I am from these research centers, okay, nanotechnologies and catalysis research centers. Okay, so thank you a lot, okay, from Aguns that give me a very detailed of introductions, so I don't need to introduce myself anymore. Okay, and I will, together with all of you, today's and tomorrow's, about the topic of biomass to energy. Okay, so yeah, so but then today we'll focus more on upgrading of the biomass into variables of renewable diesel, as well as this biojet fuel. So basically, the lessons here will be more on generals to more specifics. I will tell you about my experience in doing a real research, like for the master's or PhD research. Okay, in case you guys interesting after your graduations. Okay, so okay, let's move forward. Okay, today's outline here, we will talk slightly about this global warming and the climate change, which is highlighted by Dr. Adi just now about climate change, especially in Jakarta, right? They have very warm temperatures that everyone can feel it. Okay, instead of in Malang. So we will talk about these biomass scenarios and fundamental chemistries of biomass, which is relevant to your the agriculture topic. And we will have this, how the biomass upgrading process, okay? And then we'll look into more specific of the case study, how my research, how the research in to conduct all these solid waste, solid biomass to biofuel, or liquid biomass to biofuel here. Okay? So, okay, let's get some warm up first before we go into more details. I think everyone here, maybe your lecturers have been telling you about this global issue. This is very important, and all of us must know about this global issue from this United Nations. Okay, so we don't know exactly what the content of each issue, but at least we have to aware of this. Okay, in fact, they have 22 global issues for the whole wide world here, and what we are looking is actually this climate change first. Okay, so climate change is like a long life of learnings that is happen on all of us. Okay, we can feel it, we can see it ourselves. Okay, so don't escape away from this climate change, which is one of the global issues for a long year. That's why once these global issues have been raised up, United States also come up with these sustainable development goals. This one also very important. I believe now everyone, all the university is talking about these sustainable development goals. Okay, so do you know what is the SDG that you are learning from your course? Anyone can answer? 1, 2, 3, 4, 5, 6 to 17. Which one is the one relevant to your coursework? Can see or not? Yes or no? It's something about energy, right? So 7, right? It's talking about energy. 13, talking about climate change. Okay, so temporary lah. Temporary, I think this is the two, it might relevance to the topic that we discussed today. It might have more that relevance to your course, okay? But from the topic that we present here is more focused on this affordables and clean energies and also the climate change, okay? So at least you know what you have learned today. Is it dearly or close to the SDG that is mentioned by the United Nations, okay? So yeah, the climate change is always linked with the global warming, okay? It's a linkage. You have your climate change, then you have your warming in everywhere. So, but they have different definitions here, okay? You can see climate change is about regular changings of the average weather. It's more broad about weather, changings of the weather. So what is the changes? For example, like, yes, temperatures. Our temperatures all around the environment. Precipitations. The precipitations here means the humidity, okay, the waters, the raining. Yeah, we also have humidity and the winds, okay, and constants of wind, strong wind, poor wind. So all this is changing time by time. The atmospheric pressures, oceans, and temperatures. Okay? So this is about climate change. It might be a slightly change, but this slightly change, in fact, it will cause a lot of issues that I can show you later. So links to the climate change is global warming. Okay, one of the things about the temperatures, okay, increase of the temperatures worldwide. So our Earth temperature is continue to increase. Okay, we can see the chart here, which is about the concentrations of carbon dioxide. Okay, where we have increase of this carbon dioxide. Okay, in the ppm concentration. Okay, the red line. So you can see the increments of our global, the Earth temperature is going to increase. You might think just the 1 Celsius increase, what's so big deal? What's so serious to all of us, right? So it's okay. You just continue with these questions. I will tell you the answer later, okay? Okay, so this is just a diagram for your reference. Okay, you can see before 2017 is considered pre-industrial level. That means in this zone here, the industry activity is not really so active, but then the warming is already continue to increase. Okay, so after this 2017, you can see we estimate the warming rate will be very slow. Okay, just go above this 1.5 Celsius. Okay, just now I mentioned to you the increments. This is the increments of our Earth temperatures. It's just like every 0.25 increment, right? So why they set a limit here? Why they set 1.5 Celsius is our maximum limit for the increase of temperatures, our Earth temperatures. 1.5 is limit. So by estimate of when, probably is 2014, our this increment will reach 1.5 Celsius. Okay. So what is so important? Increase of 1.5 Celsius can affect what in our daily life? Okay. So let's see. Okay. So this is the climate risk, which is the answer of increments of 1 Celsius, 1.5 Celsius, or 2 Celsius. Okay, so scientists already take note and raise it up. 1.5 Celsius of the increment is our maximum limit for the Earth. Okay, you can see that if let's say the temperatures go up to 2 Celsius, what will be happens here? Everything is our whole ecosystem having a big changes. Okay, so you can see start from here, the sea level. Okay, and within the 1.5 Celsius, in fact, they have this 46 million people will be affected. Affected by what? The sea level increasement, okay? Well, if let's say your temperatures go up another 0.5 Celsius to 2, okay, you have 45 million will be affected. Because the sea levels increase, definitely they have a lot of floods or a lot of issues occur, okay? So next is also this Arctic sea ice. There's more ice to be melted. We know that once the ice in this Arctic area melt, definitely the same things, it will cause a lot of flood issue and the animals, the polar bear will be extinct, right? So this is not for human only, it's for the overall ecosystem, okay? Then we will have very extreme weather. You see, in 1.5 Celsius, it is 100% increase of flood risk. When you go to 2 Celsius, it's 170%. So where is our land? The land is getting reduced and limited, right? So then we have this water availability. Yeah, we have a lot of water, right, from the sea ice, because the sea is rising, and then they have a lot of melt ice, but then it's not same, okay? We having issues of drought, okay, very dry seasons. There we don't have a proper of crop plantations because it's limited of waters, okay? Then our people, what have been affected by our people? 9% of the world populations will be exposed to extreme heat wave, okay, at least once every 20 years. So when you raise up 2 Celsius, it's 28% of the world populations will be having these issues, okay? So a lot of illness will be come out after this. Also, yeah, cannot avoid also all these species in the ecosystem, right? We can't just think about our people. We also need to think about the animals, the insects and plants. So all this will be affected very significantly, okay? So yeah, by the time when the Celsius is increased, the temperature increase, so our plantations and all these crops activity will be affected as well. So that's why how important is this increments of 1 Celsius or 0.5 Celsius here. Okay? So yeah, what this caused the climate change? Okay, I think this is a very common that everyone will be know. Okay, all this climate change or global warming is caused by the greenhouse gases here. Okay, so what is the greenhouse gases? They have how many? 1, 2, 3, 4. Okay, they have 4 main gases that is grouped under this GHG, greenhouse gases. Okay, so these gases is very powerful. They can trap the heat. Okay, and trap the heat. So if let's say it's around the Earth, they trap the heat. It looks like a blanket that is wrapping the Earth. Okay, this can't go away. That's why we have our global warming here. We're just briefly gone through like carbon dioxide. Okay, we know about this. The majorities of the content about GHG, 75%. So it's how it's generated. Usually is from the fossil fuels, natural gas, solid waste. Also, when you're burning something, you come out with this carbon dioxide. Then the second is the methane. Methane with formula CH4, okay, methane. Also, it is from all these fossil fuels, okay. Then we have this nitrous oxide as well. This nitrous oxide is the gases that is generated during our human activity, okay. All these agricultural activities are, which is the main contributors of nitrous oxide, and also these fluorinated gases. So this fluorinated gas is usually is a synthetic gas, and last time they used a lot in the aircon, okay, but now they changed to helium gas. So before this, a lot of our aircon is using this fluorinated gas to generate the cold air, okay. So now it's changing already after they realize this is one of the gases that is harmful to the environment. So yeah, this is overall ideas that I mentioned just now, how the greenhouse gas affect the overall of the system here. So if let's say this zone is trapped by the GHG, greenhouse gases. A normal of greenhouse gas effect is the heat generated from the solar, the sun, okay, solar radiations, and also the heat generated from the human activity, they still can re-radiate to the space, okay? A normal concentrations of the carbon dioxide. So they still can release to the space the heat. But then when your carbon dioxide or GHG gas is going to increase, they form a very firm and thick layer, okay? So they only keep absorb the heat from solar and also the heat from the earth, okay? They can't release to the space. So this is the way that you make your earth getting warm and warm and warm, okay? Yeah, this is also the general ideas of from where this CO2 is contributed. Okay, usually the main is from these economic sectors. Okay, majority is from this electricity and heat productions, followed by those manufacturing and constructions here. And we have this 22% is for the transportations. Okay, the rest is for residentials and others purpose. So what we focus right now in this lecture is more on this 22%, which is talk about these transportations. Among these transportations here, can see in fact the automobiles, okay, the passenger car is contribute quite big numbers of the CO2, followed by those truck. So automobiles car usually right now what we're using is petrol. Petrol is like gasoline, okay, and the truck is more on diesel, petrol, diesel, and we have this aviation industry, okay, all this aeroplane here that is using the jet fuel, okay, so it's also one of the contributors of carbon dioxide. Then we have all these shape and this is marine sectors and railway sectors, which is all the train, okay, that is using the diesel here. So yeah, that's why from here we are learning, try to focus on those like the diesels and biojet fuel, okay, renewable diesels and biojet fuel that is focused on these two sectors, okay, trucks and aviation sectors here. Okay, so far okay? Right? Do you have any questions? Or we'll just keep it to the end? Okay, then I will just continue. Okay, also remind me, I'll go, let's say more than time. Okay, so if we have getting some warm up already, right? About the current issues and more real pictures about this CO2 or greenhouse gas, global warming and climate change. So now we're back to our topic about agriculture and how agriculture linked to this biomass chemistries and the scenario of the biomass here. Okay, I think this is quite general, and you all have been know about this. Is the definitions of biomass here. Okay, biomass, do remember, is about renewable. Do remember, biomass is involved this organic matters. This is very important. The biomass is come from the organic matters. So what is organics? Organics, we already talk about organic food, right? Organic is natural things, organic food. So organics in chemistry is about this content, okay? Organic is you have your carbon, you have your oxygens, hydrogen, nitrogen. This is the organic material, okay? But it must be come from living organism that only can be classified as biomass. Okay, so plastic also is organic matter, but it is a synthetic organic. Okay, because plastic also have this carbon, hydrogens, but then it is not natural or renewable organic. It is a synthetic organic. But biomass is natural and renewable organic from living organism. Okay, so also their waste product is considered the biomass as well. Okay, and the biomass they have this large compound of this carbon-based compound. Okay, and this compound is within the agricultural residues or within the biomass as a feedstock. Okay, so do remember they have around 45 to 55% of carbon. This is the average percentage, and they have a high content of oxygen. Then they will have a certain amount of hydrogens and also this nitrogen, COHN. Okay, it represents organic metals. Okay, so this is the basic ideas of the biomass we have. Okay, and then how it can generate energies for our transportations, also for the electricity to the whole ecosystem. Okay, we look more detail later. So yeah, about the biomass resources is everywhere in our daily life. We have this like forestry products, okay, wood, okay. So it comes from logging or the waste wood or those industry process that generate something like sawdust, okay. So this is all the forestry product. We have the agricultures come from the crops and harvest residues. Our food processing waste like for example like the sugar cane, right? Sugar cane we usually will generate the extract the juice to produce the sugar. What about their residue? So the residue is very useful. It's classified as a biomass in agriculture product as well. Then we have this municipal waste. Okay, those sewage, sludge, organic components. Okay, so all in this group. And don't forget we have these conventional food crops. Okay, that means those vegetable oil. Vegetable oil that we generated is considered the biomass resource as well. Okay, they have edible or non-edibles of vegetable oil. So from here, we can classify that these three biomass is suitable for heat and power or electricity productions, while the food crops is more on like liquid fuel, okay, productions, where we will go to more details later. Yeah. Okay. Sorry. Okay. So just a basic idea. Do you know why is the biomass having this energy? Why we're always talking about from waste to energy or bioenergy, okay? So where this energy is come from? Why all these plants here, they have energy? Do you know? Okay, so you might know lah, okay? Okay, I'll just briefly tell you, because all this energy is come from solar radiation, come from our sun. Our sun give us the energy, okay? How they give the plant energy? They have this photosynthesis, right? Photosynthesis we've learned maybe in our secondary school or high school. So photosynthesis is a process, a chemical process to generate food, right, for the plant. So in more detail, in more chemical or scientific way, is the solar energy here. It will transform into chemical energy and store in within the plant. It's stored in the form of glucose. Well, this is the glucose, that means the food that is generated from the plant or tree. So I think this equation is very blur. This is the equations for the photosynthesis. You need a sunlight, okay? You need the water, and you need the carbon dioxide from the environment, okay? So that the tree can doing the process, can generate the food. The food name is glucose. The glucose, they have what? They have this CHO, okay? So it is an organic matter, okay? Renewable organic matters that we talk about. And he will release the oxygen. So how powerful it is? It can generate food, it can store the energy, it also can reduce the carbon dioxide, while at the same time he releases the clean oxygens to us. Okay, so that's this photosynthesis come from, and when the biomass, or the tree is burned, the chemical energy in the biomass will be released as heat. So the plant here, when you burn, then you produce the heat. Okay, the heat is the energy that we talk about here. But burning in this way is not good. We need to have more proper and efficient ways of burning so that we can fully get all the energies from the plant. That's why it is better to convert to the liquid fuel, or you can convert to the biogas so that you can burn the fuel more efficiently to get 100% of the energy recovery here. Okay, so this is videos for you to have ideas on how the biomass work. Okay, let's watch the video together.
How biomass works. Biomass is the name for a range of organic materials that can be used to produce energy. Examples include forestry products, energy crops like
Just go to the speaker. They don't have the link, is it? Oh, so it's okay. Maybe I can translate it. Okay, supposedly they have the sound. Okay. Oh.
how biomass works.
You have the
Biomass is the name for a range of organic materials that can be used to produce energy. Examples include forestry products, energy crops like miscanthus, also known as elephant grass, and agricultural byproducts like straw. We can generate heat or electricity from biomass in a way that is close to carbon neutral. Over the material's life cycle. To understand the environmental benefit of using biomass, let's look at how fossil fuels like coal, oil and natural gas are created. Plants absorb carbon dioxide or CO2 from the air as they grow. When they die, some of the carbon from the CO2 remains trapped in the decaying vegetation. Over millions of years, these buried layers of vegetation are compressed and transform into either coal, oil, or natural gas. The carbon that was removed from the atmosphere is effectively locked underground. Now let's look at two ways you could heat a house. The first example uses a fossil fuel, coal. Coal is extracted from the ground and transported to the house. This process produces CO2 emissions. The fuel is then burnt, providing heat. CO2 from the fossil fuel is released into the atmosphere, increasing CO2 levels. Coal reserves are being depleted and atmospheric CO2 levels are rising. This life cycle is unsustainable. Let's look at a biomass alternative, in this case, wood. A tree grows, absorbing several years' worth of CO2 from the atmosphere. The carbon from that CO2 is trapped within the tree. Firewood is harvested and transported to the house. This process produces CO2 emissions, and we will come back to these later. The wood is burnt, providing heat. The CO2 absorbed by the tree is released back into the atmosphere. New trees are grown, and the cycle continues. The fuel is being replaced, and CO2 emissions are minimal. This life cycle is sustainable. CO2 emissions from processing and transportation can be offset by growing more biomass than is required for fuel. We have shown how biomass can heat a house, but the idea can be scaled up. Instead of using the wood for heat, it could be used in a power station for generating electricity. To be environmentally beneficial, the life cycle must be well managed. If we use biomass faster than we grow it, we end up with more CO2 in the atmosphere and deforestation. This is unsustainable. If we grow enough biomass to replace what is being used, we have a sustainable system. It would even be possible to reduce atmospheric CO2 using this model. Well-managed biomass can be regarded as a source of renewable energy.
Yeah, so this is the ideas of the CO2 generated from the fossil fuels. Okay, there is not a cycle. Okay, the CO2 will be released and it will be go to the atmosphere because it's excess of CO2 will be generated from the fossil fuels. Well, let's say the CO2 is generated from the agricultural waste or biomass. It is considered a cycle of CO2 because the CO2 will be absorbed back for the plant during the photosynthesis. Okay, and then they generate a new a fuel again for the burning purpose. So, how this biomass is working here?
How biomass works.
Okay, so yeah, now we're talking about these chemical compositions of the biomass. We know that biomass, they have these organic matters of carbon, hydrogens, oxygens, and nitrogens. That one is a simple idea. From this CHNO, do you know actually this CHNO is all about this component here? Okay, during the photosynthesis time, okay, they form this glucose, carbohydrate or glucose. Okay, so this glucose, when they have a lot in a plant, they will form some things like cellulose, hemicellulose, or lignin. That's why you have N here, because it is a polymer ring. Okay, it will contact one glucose unit to more than 100 units, and then it gives it a name of cellulose or starch or hemicellulose. Okay, with C5 ring. Okay, fructose. Okay, other than glucose, they might fructose. Okay, also the lignin. So that's why when you see all this biomass here, which is like sugarcane bagasse that is extracted, after you have juice come out for the others productions, and you have your this wheat cob. Okay, you grind it into the biomass form, a powder form. Okay, when you check it, in fact, they have majorities of these cellulose fibers, followed by hemicellulose, and you have lignins and others here. So this is the ideas of your compositions of your biomass, okay, which is more complicated, other just than CHNOS here. Okay, yeah, this is another angle for your review. If you have a plant, when you zoom in to the plant cell, okay, the plant cell wall, when you zoom in and see, this is all this microfiber in the plant cell wall. Okay, when you further check into more details, yeah, you can see something like this. This is the yellow color fibrous is a hemicellulose that is wrapping with our cellulose, okay, and crystalline cellulose. So when you further going down, yeah, I see very high orders of crystalline cellulose. So when you further zoom in and see, actually all is the glucose here. Okay, the glucose is arranged properly in a line form to form this cellulose fiber. That's why you have your cellulose, hemicellulose, and lignin in your biomass components here. All this is generated during the photosynthesis time. Okay? And now we give you some topic ideas of biomass scenario in Malaysia. I believe it will be the same. Okay, something similar to the Indonesia scenario as well. Okay, in Malaysia we have around 80 million tons of this biomass. Okay, dry tons of biomass. Within it, they have 85% is come from the palm oil industry, right? Because they have rich in this palm oil productions. So from here, it have generate a lot of this solid biomass, also the oil lah, okay, oil from the palm oil. Then, other than the palm oil, you will have like the residues, like palm fronds, palm trunks, and different bunches, palm kernel shell, mesocarp fibers, and also this palm oil meal effluents. All this you need to know because this is our very preserve of materials for many types of process. Okay. Then we will have this municipal waste. It's the second largest of the biomass in Malaysia. Why municipal waste is a biomass? Because they also is organic matters. It's just in a waste form, right? They also have this CHON. But certain, not 100% of the municipal waste here is biomass. In must certain portions, 50% of it is grouped into the biomass. Then we have all this wood industry, okay, from the forest. We have other agricultures and dedicated biocrops, and also this, the animal manure here is also the biomass that we're looking. So we have a lot of these precious resources here, okay. Shall we convert this biomass into a product? That means, shall we convert or further refine it, reprocess it to a more useful product or not? Okay, that's why this comes from a question: is this biomass a waste or a wealth? I need you guys answer. Who thinking this is a wealth? Raise up your hand. No, this is not a kekayaan kami kita. No, this is all about waste. Better throw it. Don't reuse. What do you think? No, everyone is thinking this is a waste. Who thinks this is a waste? All the things here? Raise up your hand. It's okay. I don't have answer also. I just want to see the opinions from you guys. Is it a waste? Waste? Or is it a wealth? It can generate more money from the biomass? Yes, raise up your hand. How many? No answer, don't know. Don't know this is waste or wealth. We have a lot here, in Indonesia, I think they have a lot of this biomass. You need to be focused. When you go back home after you eat your orange or apple peels, think about it. How I should use that things. Is it just throw in the garbage? Throw as a garbage, is it? Or you can use for something better. Think about it, okay? So I also don't know whether it's a waste or a wealth here. Because you're talking about wealth, yes, but you need to have many process to convert it into a more valuable product. When you have many process, then many money come into your mind. You need to do this, do that, until the final product. When you talk about it is waste, yes, it's a waste, but you still can change it, is it? Or you want to throw it just like that and then let it to degrade and release something, bacteria go to convert it to something not useful, is it? So yeah, they have a lot of questions, waste of wealth in a biomass scenario, okay? But in Malaysia, we are very trying to focus on this biomass, okay? This is one of the policy that is developed in 2021, where we call this 12 Malaysia plan. We're very focused on biomass. We want to really doing something up from this biomass industry, okay? Because we hope that this is one of the sectors that can generate the income and boost the economy of Malaysia. Okay, so some general plans from Malaysia is we try to doing something more comprehensive of biomass policies. Okay, so that we see how we can reuse from it, and then we wish to develop something local technology through the research, development, commercializations, and innovations. And yes, we are thinking of high values of products, and we want to promote something on very values of things from these biomass products here. So this is some of the statistics that have been done in Malaysia. Okay, among this biomass, it can actually convert into 4 very potential sectors. Okay, we can convert it into bioenergy sectors, bioagriculture, eco-products, and biochemical sectors. So from here, they come out one business model. They want to see which sector giving the most economic value here. Okay, in fact, it's biochemical. That means we try to convert all these waste, all these agricultural residues, and make it into the biochemical sales. But then this is, it need time. It need a lot of cost. Okay, they need a lot of this capital costs here to slowly convert it into the biochemical, and it requires time. So probably is bioagriculture and eco-product is the most middle ways, potentials and feasible ways we can go. Okay, that's why the entrepreneurs in Malaysia and also the scientists in Malaysia, we are trying to convert the biomass into what? Fertilizer, animal feed, aqua feed. I believe is the same in Indonesia here. And also the eco-products, like you can convert back into the paper, composite, packaging, something like carbon, right? Fiber, plastic, okay? And it need a medium of time. But don't forget the energies also is a very potential of sectors that is straightforward we can go for, right? For the bioenergy, it just require a shorter of time frame, and you can come up with the product and the return, okay? Although the economic value is not high, because at the end, all these things will be burned as energy, right? So the economic value is not good. But then you bring a more fruitful of output. What is that? It's our environment. He bring back to our environment. He save our environment, right? Because we are using the bioenergy here, okay? We're using the biomass here to generate the energies. So the GHG gas will be reduced. When the GHG reduced, then it save a lot for our environment here, okay? So we can maintain our global temperatures within 1.5 Celsius, okay? So this is why all these 4 sectors here is potential. I can say it's potential, but we need more smart people, entrepreneurs, and scientists to develop the technology, okay, which can thinking about the cost, about the process, and about the whole ecosystem, so that it won't affect anything while you have a good product here. Okay, so yeah, shall I continue, or you guys need any rate? I just continue, right? Okay? Yeah. Okay, so that's why when I say about these 4 technologies, 4 sectors here, now we are talking about this biomass refinery. How we doing this refinery here to get our variables of product. So this is the generals of the biomass conversions technologies. And what I focus here is about the bioenergies. I'm not focused about those like eco-product or bioagriculture products or biochemical, but today we just focus on the biofuel. What is the process that way we can use to generate those bioenergy? Okay, so the simple one, you can have this thermal process, biological process, and physical process here. We know that the whole system here is called top-down process. That means from a very big and bulky material or bulky biomass, very big, right? Then you retune to a small and then a small product. Okay, so this whole process is called top-down process. Okay, sometimes the top-down process it need more energy to do it, to process it. It need more cost, more treatment. That's why this is our concern here, whether it's still a waste or it is a wealth to us, the biomass. Because when you use more energy, to process the things. Do you think it's workable? You use energies and produce energy. Does it make sense? You will spend more energy from this process. At the end, what you want is energy as well. So you use energy and produce energy. Sometimes people say it's not work, but then definitely we don't have answer. Okay, we need persons. We need the persons to come to continue to make more effective, efficient technologies so that we can have more purpose of our process to convert the biomass into all this bioenergy here. Okay, so we have the general combustion, pyrolysis, and gasification. This one, they need a high temperatures process and pressures. Then we have this biological, which is, I believe you guys learning now, which is more promising of process as well because they are using more mild condition compared to the thermal process. Then we have this physical here means is we have the seed. The seed will be squeezing the seed into oil. Okay, this oil you can as a burning of vegetable oil for further upgrading process here. So in another way, we are looking in another angle. Okay, you have many types of biomass, right? It's not just agricultural residues. You have the biomass. Is it very blurry here? Okay, you have these oil crops, which is like vegetable oil, and you have this sugar and starch plant. Okay, so you have all this solid biomass and wet biomass. When you have one biomass, you can't simply just say, okay, I want to convert into biodiesel. I want to convert it to the biogas. No, you need to see whether it is suitable to become the biogas or not, or biodiesel or not. So that's why we come up this diagram here. You have 4 types of feedstock, and each feedstock here, they have difference of process. Convert it into your desirables of product. Okay. That's why like vegetable oil, we know lah, for example, like palm oil. Palm oil definitely is for trans-esterification because this is very common that we can generate the liquid biofuels or biodiesel. Then when you have the sugar base of crops, for example, like sugar cane. Yes, sugar cane, they have a lot of sugar, right? So other than sugar cane to be extracted as the juice, actually the sugar cane can be produced this bioethanol, okay? Which is the bioethanol is what we have like our gasoline fuel for the passenger car, right? So we need to have this pro and con how to use these edible food crops for the bioalcohol productions. When you have those solid biomass, something like waste, solid waste from our palm oil industry, okay, like palm kernel shell, those mesocarp fiber. So this is where you can doing something like pyrolysis or gasification, right? In order to produce oil-based or gas-based of fuel for heating or burning. Then when you have wet biomass, that means the biomass is very wet, like those animal dung is wet form. Okay, so this is suitable to doing some anaerobic digestions to get your biogas here. So that's why different feedstock, they have different technology here. Yeah, this is another process that tell you that different technology give you different soft energy product. So you can't use digestions and get heat. You can't use fermentations and get electricity. You need to think properly what technologies, what process you want to use. Okay, in order for your energy product that you choosing for your final product here. Okay. Yeah, I mean this is I think a general and overall of the pictures. Okay, for the biomass biorefinery here. Okay. So here's go into our case study. Okay, where my research team is doing the works. Okay, we have know the chemical compositions of the biomass is very complicated, right? A lot of rain, a lot of polymers, how it can make a proper of final fuel product. So here the challenge to unlock this biomass chemistry. Okay, that's why we have two studies here. You imagine that your biomass is in solid form. How the solid biomass can change to liquid fuel? Yes, from solid to liquid fuel, right? This is the study one that we're going to talk about. And the study two is about the liquid biomass. Liquid biomass here, that means like for example, like vegetable oil, okay? We want to convert those vegetable oil to biofuels. This is more simple and straightforward. But the challenge here is the solid biomass here, okay? So yeah, before we go into more detail, this also the challenge that we're raising here, okay? We have biomass. Liquid biomass is what I mentioned. Like we have this waste cooking oil. We have this palm oil effluent, which is the byproduct from the palm oil industry. They wash, because once we extract the oil, it's not ready for using for cooking, right? Then still need to wash and treatment in order to get oil that is ready for cooking. So that they produce a lot of this waste water called palm oil effluent. Then we also have this byproduct from the palm oil industry, palm fatty acid distillate. Okay, all these things, they have this structure, triglyceride structure, okay? So this is the structure, I believe you all is chemistry based, right? No, they are not chemistry based. So you understand about this structure. Okay, so within it they have these carbons, and because I'm from chemist, I'm considered a chemist. So what I'm talking about, everything from my angle is a chemistry, okay? From the chemistry, how we unlock the possibles of the products, okay? So yeah, come from, this is a biomass, because they have C, they have O. Oh, the C is not written here because this is the formula they have. Okay, all these sharp corner is a carbon here, okay? So yeah, they try to unlock these triglyceride structures. And then we have this solid biomass. I believe when you all saw this structure, you already want to vomit. Right, that's why we are looking at all this structure here. This is cellulose, is a long chain, hemicellulose and lignin. So we are thinking to convert it into those biofuel, oxygenated aromatics, fuels and materials. And this is what we call biorefinery here. And the whole process here is, I say, top-down process. Why? First, they need to defunctionalize. They open the structure. They want to cut here, right? So to become a small molecule, right? Then that you need this catalytic system. Okay, catalytic is something like additive that you put together with the reactions to increase the efficiency of the reactions. After that, you need to functionalize again, to join back all these maybe small part of the chemical, okay, into your desirables of product here. So in a simple way, it's a top-down process from defunction, the structurings of the compound, and then reform the compound, okay? So this is the idea our group is focused on. Okay, so yeah, I go to my study here. So this is more like experience to you guys' lives, okay? So just a knowledge for you all. Yes, we see the beautiful pictures here. This is what we have from your plant, okay? How beautiful is all these things in our naturals here, okay? When you zoom in, you see all these. This is the cellulose. This is the drawing that translate from my students. They try to convert it into a graphic, okay, but it's not that perfect, but it's still understandable, right? We have this cellulose fiber here is in like they are arranged in something like pentagon. Okay, pentagon of this is what we have, the cellulose fiber. With the cellulose fiber, you are wrapping with all these red color things. This is the hemicellulose we are talking about. Okay, then it's not really shown here about the lignin. Okay, we also is wrapping by the lignin, which is the outer part of the tree, right? The brown color one is actually the lignin. Okay, so it's wrapping by all this lignin here. So now we want to destruct this thing. Okay, destruct it. You see all this formula here. We want to destruct it so that we want to get carbons and hydrogen. We don't want oxygen. We don't want oxygen. Oxygen is not good for the field. Okay, we just want carbon and hydrogen. Why? Later I show you. Okay, yeah, this is some of the ideas about how we pyrolyze it, high temperature process, okay, to heat this solid material and then become a liquid. The liquid here is black color, it's called bio oil. So this whole process here is called pyrolysis process, okay, a very high temperature process in the absence of oxygen. Okay, we want to extract the things within the compound, decompose the structures so that it will form like this. And this black color oil, in fact, they have a lot of organic compound within it. Okay, a lot of things. They're very complicated. Okay, so within it they have water, lignin, aldehyde, they have acid, carbohydrate, all these things. From there, what we interesting is just 15 to 30% here. We are interested about all these phenolic structures. We are interested about this ring structure. Why? This ring structure actually can be mimicked. Okay, it has the same structures like what we got from our petroleum oil. So that's why we want to study all these potentials. How we're going to retune all this structure while we want to remove the O. We don't want O, we don't like O. We don't like O, oxygen, in the field, okay? Because it will reduce our energy, the field performance, okay? It will less energies and less powerful. So that's why we try to retune it and remove the O, oxygen from it. Yeah, this is the answer. Why I say I just like carbons and hydrogen, I don't want oxygen, because this is the fossil fuel we have. The fossil fuels is mostly the compound of carbon and hydrogen. Okay, okay. All this is what we have in the petroleum. Okay, we have saturated compound, unsaturated compound. You have the ring form. You have this paraffinic, that means a long chain or short chain without a ring form. So when we back to here, we have this aromatic compound, and we don't want oxygen, right? Because we want to try to make it to all these fossil fuel here. Okay, let's come to our project. Okay, we are using the lignin. Okay, and we convert it into the bio oil. Okay, from it we found that they have majorities of both of these compound, glycol and dibenzofurans. So from here we want to convert it to cyclohexane. We want to convert it to bicyclohexane. You see, the product here is without the oxygen. We want to cut it. Okay, convert it. Okay, so this is the most simple way to do the student. Okay. Yeah, that's why in a master or PhD project, it will come something like this. You want to convert this glycol to cyclohexane, dibenzofurane to bicyclohexane. You need a system. It's not just heat with certain time or temperatures, then you got it. Cannot, okay? You need to presence of a catalyst. So what we focus also, we need to, the scientists we're thinking of potentials of catalysts for this process, okay? So that you get high products of all these Okay, that's why this is very deep, deep of how all this system from this catalyst can help to convert the glycol, convert the lignin compound into the final cyclohexane product here. Okay, that's why we are using something like high pressure reactors in the laboratory. Okay, and the system here, we have the bio oil. Okay, and it will install with the catalyst. You see, the catalyst will be put in this form. Okay, installed in that reactor. So once the stirring turn, it will break this glass. Then the catalyst will be released into the reaction medium, and the reactions will be start. Okay, so this is the temperature conditions that we need. Okay, to process this whole reactions here. At the end of the product, we want to see whether this is the product that we need or not. So what we need to check? We need to use the chromatography. Okay, chromatography GC. Okay, chromatography GCMS and GCFID to check the compound. Yeah, I think this is also roughly gone through, because we need to know the amount, okay, we got from the process, right? So you see, when we want to convert the glycols to cyclohexanes, they face a lot of challenges. Okay, it's not like what we are thinking, from glycol straight to cyclohexane. No, okay, it passed through many type of intermediates first before he go to our desirable product. So this is our challenge here. How we make sure the whole process must be reached here. I don't want to stop halfway in phenol cyclohexane at here or at this cyclohexane. I don't want. So this is the issues. We need to adjust our temperature. We need to adjust the pressure, and we need to find out a very good catalyst that can bring the whole process from beginning to the end of product. So you can see here they have a lot of intermediate, and what we want is cyclohexane. Cyclohexane is this one. Okay, it's a black color slope line. That means this one. This is what we consider the best already. This part with this catalyst, but it still have unavoidables of intermediates. You see, so this is a challenge here. But the effort, continuous study is still ongoing in order to get the best process at the end of the study, right? Yeah, the same. I think this is the same for another compound. It's quite complicated. Also, it's not from here straight to here. It's passed through many steps, okay, before you go to here. So again, it is a waste of wealth. No answer, right? No answer. This is no answer. I cannot say it's a waste because I'm doing this project. Okay, just we need a very energetic and very innovative scientist to come out a much more good process from here straight to here, without pass through all these blah 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 things here. Okay. Okay. So okay. Also another case study of, Okay. Okay. I think we stop here first for 10 minutes break. Okay. When we come back again, we continue for another 2 study. Okay. It will be simple one. Okay. So 10 minutes. We'll come back on 10:15. 10 minutes left. Oh, okay. I think some misunderstand here. We continue for another 10 minutes, okay? I've quickly bring through the rest of the slide because the rest is more on experience from my lab, okay? Then we will end this and we will continue with the Q&A sections, okay? Good, Okay, be patient with me for another 10 minutes, okay? Okay, so I think I won't bring through this. This is very chemistry. we are just go to this something the same now. We are doing the triglyceride oil. Just now we are using solid biomass, right? Now we are using the palm oil for the process. Okay? And yeah, the same things we are doing all these reactors to perform the study. Yeah, I think the same from triglyceride is something different with just now the phenolic ring, the aromatic ring. But the same things, what I don't like oxygen, right? I don't like oxygen, but normally I need oxygen. But in the process, I don't like oxygen. So I need to remove all this oxygen, okay? So you need to find a way to break it to the small compound, and then I cut it, okay, remove the CO2, remove the water, so that at the end, you see, all this compound here becomes carbons and hydrogens without oxygen. Okay, so you see, if let's say you still remember all these compound from petroleum, it is something like this, okay, which is what we need for the bio-renewable diesel. Yeah, I think this is a pass-through. Yeah, the same thing we will study here to see the yields and selectivities, whether it is more on renewable diesel. Renewable diesel, they have a more longer of change, while the gasoline, they have shorter of change here. Okay? Yeah. So something about biojet fuel as well. Okay, I'll make it brief lah. Okay, we just see on this graph. This is the fuel. Okay, fuel from the fossil. So now what we are using from the petroleum fossil fuels is all from here. When we see about the car, they need how many carbon number? This is the gasoline from C5 to C15, C6 to C9 lah. Okay, we see from this graph. Okay. That's why from here, this is our ideas on how to retune all this biomass to this carbon number. C6 to C9 for gasoline, and then for kerosene is what we say about the jet fuel, okay? The jet fuel, they need 9 to 15 here. And while the diesel, they need something like 14 to 18, okay? This is the idea for you to know you want to produce what products. From here, you think about your process. Then only you start your project, right? Okay, the same things, aviation industry is bringing a lot of this GHG, okay? You can see it is very, produce all these gas, carbon dioxide, nitrous oxide, water vapor. Water vapor is one of the gas that can affect our climate, okay, the global warming. So the rest like particles all is very significantly impacting the global warming here. Okay. That's why what we come is to produce this sustainable aviation fuels, which we want to make sure a CO2 cycle, zero cycle here. Okay. Then from here, we also have actually all the biomass here can be converted to the biojet fuels. The same for sugar starch, oil crops, cellulose and waste. And I believe you can't see this anymore. Okay, this is the same what I mentioned. We have all these sugaring and how we convert these carbons into the jet fuels, how we convert the oil crops, which is in a fatty acid chain, okay, how we convert into these cyclic alkanes and paraffin. And we have this cellulose, hemicellulose here. All is for chemists, it is a very precious of material, okay. Even a waste, municipal waste. Your municipal waste actually also involve all this lignin, hemicellulose, oil and fats. But one thing is we can't avoid is the plastic. Plastic actually is a very potential synthetic organic compound that we can convert into the fuel, okay? But it is a synthetic, right? So the biojet fuel, it can have very many routes here: alcohol to jet, gas to jet, oil to jet, and sugar to jet, okay? And yes, it's not easy as well. it gone through a lot of these many reactions pathway in order to get our biojet fuel. Okay, so this is a basic idea here, but I'm not going to bring into details. Okay, most important is you know that different feedstock, okay, it's possible to get your aviation fuel. Okay. Yeah, so there are a lot of reactions that in future you can know more. Okay, so in our project here, one of my students is using this palm kernel oil. Why? We choosing the oil also need to have results. It's not simply just take it, because we want to see the composition. The fatty acid within the palm kernel oil, they have this fatty acid of C12, carbon 12, carbon 14, carbon 16, and carbon 18. And we foresee that this is the good fatty chains. After the conversion, he can get the carbon number within the kerosene carbon number, which is C8 to C10, if not mistaken. Okay, so that's why we are looking for this, and we are doing this deoxygenation process. We need catalyst. We need catalyst to perform it. So what we've gone through, the process almost the same, like it's same like previous one. Then we will check with the gas chromatography here to check the composition. So this is what we got it from the GCMS, okay? Because you have the oil, you have your product, it's in yellow color. But how you think it is correct or it's a true product or not? Can't just try in our car, right? Or try in the aeroplane. So we need to do this GCMS test to see whether it is the right compound. And what we need is from C8 to C16. This is our desirables of liquid product for jet fuel, okay? Less than 16. So then, just now this is the, previously is the standards of spectrum. Now we see what we have here. We're using palm oil, we're using waste cooking oil, we're using palm kernel oil, okay? So this is our product. And you see that this oil is within the range of carbon C16. So that means we are successful to produce the jet fuel here, okay? This one is okay. I just tell you that from there also we are studying the compositions, right, in a jet fuel. And we prefer more on paraffins and isoparaffin, where it will have high hydrogen to carbon ratio. Okay, we don't like olefin also. Okay, olefin it will reduce they have the stabilities of the overall of the fuel performance. Okay. Yeah, this is the same. I think it's more on mechanisms on how we cut the oxygens, and at the end we get this high hydrocarbons here. Okay, so yeah, from what we have, C12, 14, 16, 18, we first round of this deoxygenation process, the remove oxygenation process, we will got this carbon number 11, 13, 15, 17. Then further refines to difference of reactions pathway, it will get a more shorter of compound at the end. Okay, at the end, what you have is 8, 9, 10, 12, 14, which is within the range of the jet fuel. So yeah, this is a summary already. Just to, the overall summary is we have all this biomass, okay? Everything, remember, renewable, organic is biomass. They must have carbon, hydrogens, oxygens, and nitrogens. But for a field, if you want to apply in a field, we are not encourage too many oxygens. Okay, oxygens, it will reduce the performance. So that's why we need further biorefinery. Biorefinery is an upgrading process, okay? Different type of upgrading process that you can think, then you can do it, okay? Also, we are doing the catalytic system. So, we can make the impossibles to possibles, okay? But still the question, we don't have answer. It is a waste of wealth. Okay, we don't know. In future, if let's say you are interested to have more deep study, then you can do it. Okay, thank you for today lessons on the this liquid biofuel. Okay, thank you.
Okay, thank you for the outline presentation. Okay, now it's time to floor for the questions and the discussions. Please prepare your questions. Yeah, I see someone in the right hand.
Yes.
Please state your name and your class before asking a question.
That's okay. Good morning, Professor Lee and Mr. Agung, and also all the everyone in here. My name is Zeta, and I came from E class of Agriculture, Electricity, and Energy. And I would like to ask you some questions about what. First of all, I would like to tell you that it was a very interesting lesson from you, and thank you for that. And I wrote it before just in case I forgot. So as you mentioned, the current problem of the renewable energy is about the efficiency and also the expensive cost. And in our limited resources and also the limited time, like we are being in rush because of the condition as you mentioned before, the climate change and everything. So what is it the things that we have to more focus to increase the efficiency of the biomass, or we mass produce, and also just to make the biomass is reachable to every linear possible. Yeah, that was my question. Thank you.
Okay, thank you for your question. So, you mean that in this rushing of time, right? Rushing of time in climate change, while a lot of these biomass technologies and process is still in research, right? It's still in research, and how in these situations, what we can do to temporarily to solve on hold or slow down the climate change or global warming, while at the stage what we can do for biomass in this stage, right? So yes, first thing is I think these issues have been raised is I think more than 10 years. 10 years ago, what we have focused. 10 years ago, we are focused on biodiesel. Still remember, we are using the palm oil. We know about global change. We all know, well, I think 20, 30 years ago. So the process is still ongoing for scientists, for the governments, right, for the industry people. We are slowly in a transition of periods. The first thing what we have learned is about the biodiesel. That's why we have palm oil or vegetable oil and convert to biodiesel already. And yes, it's a very successful. And I think in Malaysia we also have this B30. I think it's B30s blending with the diesels that have been used. We already have this subsidized to the publics to use B30. 30% of biodiesels with petrol diesel for those diesel vehicle, okay? And then at the same time, what we have discussed with Agung also yesterday, we have a lot of this biogas industry, you know, especially for the palm oil industry. They generate a lot of this biomass waste, right? Pome, P-O-M-E, pome. So this is waste that if you want to use extra money or chemicals to trade it, why not you change it to the biogas? Okay, all this I believe is learned from your study, where it's called digestion process, right? So they need to build up a very big pond, okay, to have this biogas, and this biogas at the end can be used as an energy fuel, bioenergies for generate the heat and industry. So the same time, I think we can't give up on biomass. It's still ongoing. Even in Thailand, I see that they are very good in using the bioethanol. Their car currently is using this ethanol fuel, E80. 80% of bioethanol, but 20% is the gasoline. E80, and we are using B20 is diesel. Malaysia, because maybe our petrol is still controllable, the price is still acceptable. But in Thailand, their petrol price is very high. That's why they go for this ethanol, bioethanol. They are very successful examples on using this bioethanol in the passenger car. Yeah, so what I'm talking now is about our Asian country. I'm not talking about this Europe yet. You know, Europe, they are much more stable in all this renewable energy. Yeah, other than solar energy. That's why we can't just rely on biomass energy, okay, agriculture energy. Sometimes we also focus on solar energy, hydro energy, right? This is all our strong field in Asian country because we have rich in water, we are rich in sunlight, right? Also, we are rich in biomass. So it's, much more comprehensive to focus in these three parts. Okay, while we can't give up our biomass as well. This is one of the energy that it must, maybe it can use for industry. Industry, they are using the biomass to burning directly. They make it as a pellet, where tomorrow topic, I will discuss about this biomass to solid fuel. Okay, this solid fuel, they are doing some burning and get the heat in the industry sectors. Yeah, so am I answer the questions?
Okay.
Thank you for the answer. And if I may add the questions, so which one is we should focus more to increase the efficiency or the mass produce that we talked before? So that may be if I'm clear enough to address the question.
Let me mention, you mentioned about shall we focus on the efficiencies to get a product with high performance, or we are more on like mass productions, right?
Yes.
I think both both is important, but definitely the efficiency is the first come. If not, because this is the field that you're talking about, we are using in the transportation sectors. That means it is used in your car, your expensive car, right? The aeroplanes, you're using in the plane. So no matter how, the quality must become first. The field when you promote into the market, whatever you produce into the market, they need a standard. They need to fulfill the standard, something like American standard ASTM, right? Is within for the field. So all these things, even a solid fuel, a charcoal, a coal for burning, it needs a standard also before the industry can buy it and burn in your industry. The fuel also the same. Everything must come quality first. Then only we talking about the mass production. Mass production is another issue that you raise up. It's very important. I know we have a lot of biomass. But when it comes to mass production, shall we have this continuous availability of biomass? We need to make sure every year we have these 80 million tons of biomass for the biofuel productions, right? Because if not, then where is the fuel going to be long-lasting? So mass production is one of the issues that we need to solve it. How we can get this confirm and constant resources in the future. Yeah, so, and that's quality first, then only mass productions. Yeah, thank you.
Thank you very much for the answer.
Okay. Is there any other questions?
Cek. Assalamualaikum warahmatullahi wabarakatuh. My name is Jan Adib Wasalama. You can call me Adib. I'm from System Engineering Department. My question is, I believe that in the future, the use of fossil fuel will definitely be replaced by renewable energy. So my question is, transportation that use fossil fuel will simply be replaced and may not be used. What will be done to cars that are no longer used in the future? Doesn't that create new problem for the environment? Thank you.
Okay, let me confirm again your questions. You're asking what type of renewable energy can be used for transportation fuel, right?
Yes,
Okay.
replace the energy fuel by energy fluid.
Okay. So I mean, as I mentioned, every 10 years or every 20 years, the transition is ongoing for the transportation fuels. Okay. Also, having discussed with Agum yesterday, now before this, maybe last decade, they are more on fossil fuel, but in the middle age, like last maybe 5 years or 10 years, they focus on blending already, blendings of biofuel with petroleum fuel, right? This is what we have practiced and we can see it. Now, even the process is ongoing, the blending is ongoing, but then the transition is, we can see that now they invent the electric vehicle with EV car. So that means other than biomass energy, it still have another sectors that is focused on electric car, okay, that come into the market, to the transportation market. So although electric car is not renewable source, right? It's not a renewable energy, but it is another options to reduce the carbon dioxide emissions, CO2 emissions. Okay. While at the same time, biomass is not giving up. A lot of research on biomass, we try to, we are doing the liquid fuel, right? Liquid fuel is for transportation. We also try to focus on hydrogen gas. Okay, convert the biomass to hydrogen gas. In future, you will see about this hydrogen car as well. Hydrogen car, okay? But they have already, it's just that it is still not stable yet in handling the hydrogen gas, okay? So there are a lot of opportunities it still can ongoing, okay? Also, you talk about renewable energy. Also, they have this solar car, right? But then, how efficient the solar car? How long the distance it can go? So it is all is still in research. Yeah. So that's why you talk about renewable energy is everything. It's already been studied in a car, but then it's not stable. I think it's not that stable yet. Still ongoing. Yeah. Thank you.
Thank you.
Yeah. Okay. Yeah. So if we conclude, the source for the fuel for the transportation is many. There is a various source that can be used for the transportation. It's like biomass, biohydrogen. We can see like electric vehicle, and so on. And talking about the bioenergy or biomass energy that now might be already implemented in Indonesia. If you go to the gas station, you can see B30 maybe or biodiesel. We already blend biodiesel, 30% of biodiesel with the 70% of diesel or something like this one. Okay, maybe there's another questions. You can, yeah. Okay.
Okay,
Okay, good morning. My name is Beliza Dina Putri. So, related to Edith's question, my question is there any risk or any chance of biodiversity loss associated with bio, sorry, associated with a large scale of biomass use? Thank you.
Okay, thank you. So yeah, mentions about the biodiversity, is it right towards the large scales of biomass usage? Yeah, this is also relevant to the first questions just now. If let's say we have these mass productions, how we have these continuous supplies of biomass. And you know, they have a lot of issues talking about this. When we're using the palm oil for biodiesel productions, that we receive a lot of this ban, okay, from the Europe country, right? What they mention is not using the edible oil, cannot using the oil that we can eat, okay, that we can eat for humans to do something for fuel, okay. So that's the issue come with fuel versus food, okay. So the oil should be used for food purpose or the oil should be used for the fuel, right? But the story never ends because it involves a lot of political issue. It's not talking about the palm oil in Asia. When we're talking about the sunflower oil, we're talking about the corn oil, right, in other country. I'm not mentioning the country name. So they are still using that oil for their biofuel, biodiesel productions, while they restrict the palm oil to be imported as a fuel purpose in Europe country. So this is issue because when everything is enforced, like I think in Malaysia and Indonesia, the same. When we talk about to use the palm oil for fuel purpose, there's come to one regulations that is controlled by the palm oil board. Okay, the palm oil board need to know your whole process, how your plantations till your final oil extractions and to your biodiesel production. Whether the whole system and whole cycle will affect any soil of the plantations areas and pollution, water pollutions, okay, somewhere near to the forest, right, the plantations areas, and will it affect the animals that stay in the plantations area or not? All these, they need to be concerned before they approve use to have this project. So it's not project, it's for this commercialization. So I think everything is under control, and even this is not just how to say, it's not controlled by the Malaysia's palm oil board. It's also they have this international palm oil board come over and check the whole process. If this is not sustainable, what we call it is sustainable, where you have like make a lot of soil issues or the water pollutions, or you kill a lot of these animals during the plantations, then you are banned for this purpose. Okay, this is which is edible palm oil for biodiesel. When we talk about the palm biomass is cannot eat, right? It is a waste, right? It is a waste from all of us, whether you want to use it or you don't want to use it. So it's not an issue about any biodiversity system, right? Because we try to gather all the waste while being, open dumpling. Some of them, even the palm biomass after they extract the oil, they have no idea how to deal with all these solid waste. So sometimes they just dump on the plantation site as a fertilizer. But if you don't have a proper management, it still make up a lot of stingy smells and soil erosions occur. So that's why this palm biomass can be gathered and then to make a more useful of product. okay, where it won't affect the ecosystem, also the biodiversity or the species extinction here, okay. But the palm oil is a very important palm oil because it involves a lot of big scale of plantations, right? But waste biomass is a waste. We just need to collect it, but we need to make sure they have certain amount that can be sustained for forever. If let's say you launch out this biomass oil, right? Thank you.
Okay. Well, we have time for one more questions. Yeah.
Okay. Good morning, Prof. Lee and Mr. Agung. My name is Ahira Rahmani. I'm from class U. Biorefinery projects mostly arise because of the need for products, but the existence of raw materials is also the basis for biorefinery development. And my question is, because the discussion above also refers to biorefinery, so what will be the challenge for biorefineries if they are associated in the future? Thank you.
Okay, can you clarify your question? I mean, what is the... Can you explain that? One more question. I mean, can you explain it? In short, yeah.
Maybe for the product in the future or association in more about the product in.
Oh, okay. Or maybe you can explain in bahasa Indonesia. It's okay.
You mean that about the palm oil product? Is it?
Yes, Prof.
What is the issues of palm oil product?
Can you explain in bahasa Indonesia? Just I'll explain in bahasa Indonesia and I will try to translate in English.
Oke. Proyek-proyek biorefinery lebih banyak muncul karena kebutuhan akan produk. Tetapi keberadaan bahan baku juga menjadi dasar pengembangan biorefinery. Pertanyaan saya di sini adalah, karena pembahasan tadi juga menuju proses terhadap biorefinery, jadi bagaimana tantangan biorefinery di masa yang akan mendatang jika kita mengasosiasikan proses biorefinery tersebut? Apakah nanti terdapat beberapa faktor permasalahan yang muncul jika produk-produk tersebut diasosiasikan? Terima kasih.
What is the chance of the biorefineries in the future? What is the chance of the biorefineries in the future related to I mean berhubungan asosiasi dengan renewable energy?
Yes.
Okay, so okay, I think I get your questions about the challenge, right, about the biorefinery system, right, with the renewable energy, right. So I assume that the renewable energy you are talking here is for biomass energy, because this biorefinery, the name here, the keywords here is design for biomass energy. Okay, so this biorefinery names is come from petroleum refinery. Okay, we see one of the slides just now. We have this fossil fuel refinery at different temperature. You come up different product, right? So the same. We have this biomass here. Okay, how the different process can generate different type of biomass energy, right? Well, bioenergy we have here is like we have biodiesel, bioethanol, biogas, and then we have this heat okay, direct combustion of heat, or we have others small type of biofuel product. So the challenge here, as I mentioned, we already have a very good plan. We already know that this process is for bioethanol, and that process is for biodiesels, and maybe hydrodeoxygenation is for renewable diesel. But the challenge is the technical part. How you going to make this product in high quality, in high product yield, okay? Because if let's say the process is not good, it might get 15% of yield or less than 15%, right? So end up your cost is more than your cost is the production cost is more than your price of the biofuel. So it's not worth. So the challenge here is the technical part. It's a technical issue how you're going to process it, okay, with a proper technology to convert the biomass into the products. This is a challenge for biorefinery system. Yeah. And also for this is the point of view from a chemist or scientist. For the industry don't care about how you're going to do this, do that. Industry is thinking about the cost. How many energy I need to use to process it? How many waters? How many electricity? How many materials? Okay. At the end, what is my profit? What is the original? The basic price of this biofuel in 1 ton, and how many profit I can gain? This is the angle from the industry people. Yeah. So it's something different, right? So this is a challenge from industry, and also the challenge from a scientist, okay, to make it realize, to make it happen for this biorefinery system here. Okay, thank you. Very good questions from all of you.
Okay, thank you for that engaging discussion. And unfortunately, our time is come to an end. So thank you for your participation today. And hopefully you will get this discussion and this lecture find it informative and inspiring. And thank you so much for the discussion. And I will back the session to the Master of Ceremony. Master of Ceremony, please.
Okay, thank you Moderator Mr. Agung, thank you Dr. Lee Wei-Woon for sharing your expertise and insights with the head of the department and our faculty members for their presence here today. We truly appreciate your time and your knowledge. We extend our heartfelt gratitude to our invited guests, Dedean, the head of the department, and our faculty members for their presence here today. Ladies and gentlemen, that concludes our international guest lecture today. We hope you found this lecture enlightening and inspiring. Thank you all for joining us. Have a wonderful day. See you tomorrow.
You can photo session.
All right, before we end this event, we can take a photo session.
Okay. Yeah. Oke, bisa ke depan ya.
Ya, ditukar untuk mahasiswa di atas. Ya. Yang dosen ngalah ya, dosen di depan. Gitu ya. Yang mahasiswa di atas saja karena terlalu banyak ya. Ya, nanti dosennya depan saja dicoba dulu ya. Dosennya depan. Karena nggak kelihatan ya yang belakang. Nah, gitu ya. Ya, oke, Dokter Lee, Pak Agung, Bu Ina, please stand ya. Oke. Ya, Bu Ina di middle ya. Ya, oke, Bu Ina. Sudah? Yeah, thank you so much. We will get a meeting tomorrow. So please come here on time. Ya. Oke, thank you very much.
Jangan lupa presensi ya, jangan lupa presensi di depan. Presensinya di depan jangan lupa.